hello there. So we are going to work on the Your Turn to Play, which starts on page 63. And there's not going to be a lot for me to write down, but there's going to be a lot for me to talk about. So question number 1, we're talking about a definition that Euclid wrote, which is a point is that which has no part. And we're asked to criticize it. Well, okay, I'm going to criticize it. How can something have no part? Does that even make sense? I mean, if you have a something, doesn't it, by definition, have a part? Even if it's only one part, it's got a part. And we don't really know what is a part. Are we talking something that can be touched? Are we talking something that can't be touched? I don't know. So Euclid gave it a nice try, but remember that we have point, line, and plane, which are the undefined terms in geometry. They're undefined for a reason, because as soon as you start to try to define them, everything gets funky, and you find out it's a lot harder to define it than you thought it was going to be. So anyway, these are my criticisms of Euclid. Number 2, without a protractor, how would you draw an angle of approximately 45 degrees? Well, I'm pretty good at drawing right angles, and those have 90 degrees. And so half of 90 is 45, so if I just cut this in half, that would be a 45-degree angle. And so that's a pretty good guess. Question number 3 says, well, let's draw an angle of 30 degrees. All right, so I'm going to pretend like I got this right angle, and I'm going to cut it in thirds as if I were slicing pizza. So this is going to be about 30 degrees, and for those of you who are playing along at home, that would be about 60 degrees, because again, we have the 90 degrees and we're dividing it into 3 parts. Question number 4 says, okay, now Euclid is trying to define a line, and he says that it is a breadthless length which lies evenly with the points on itself. So, do I forgive him? Yes, I do forgive him, and I'll tell you why. Because he was the first guy to think of this stuff. He was the very first one. It is amazing to me that you could have someone who started with no knowledge of geometry and then makes this up. That is so stinking cool. Even though I do not understand what he's saying. What does he mean by a breadthless length? I think he's trying to say that there's no width to a line, but as soon as you draw a line, it looks like there's a width, and I don't know. It just gets confusing. So no, I don't really understand him. Okay, so number 6 says, let's talk about congruent angles and, or congruent anything. Could be angles, could be triangles, could be whatever. They say 2 triangles are congruent if they have the same shape and size. What's wrong with that definition is we haven't defined shape or size. And remember, we're not allowed to use things in our definitions that haven't already been defined. So, so no fair doing that. However, they do want us to make a definition. They say that line segment AB is congruent to line segment CD if and only if what? Well, if this is AB, and this is CD. In order for them to be congruent, you have to be able to see that they are the same. And how are we going to see that they are the same? Well, we're going to measure them. So if AB, the distance between these 2 points, if that equals CD, the distance between these 2 points, if that is the case, then the segments are congruent. Please notice the little sign for congruence. It is an equal sign with a little squiggly on top, and that means congruent. Congruent. Okay, number 8, we get to draw Fred's face, which of course I find very entertaining, but also a little bit hard. It looks like a simple face, but I don't know. These things, let's see here, like that, and like this, and then, how's that? That's not too bad for Fred, huh? Okay, so let's label some right angles. We got this one as a right angle. We got this one as a right angle. All right, we got this one as a right angle. Okay, can we find some acute angles? Well, acute means less than 90 degrees. So that would be a very nice acute angle right there. And then, can we find an obtuse angle, meaning greater than 90 degrees? I'm going to say that this right here is an obtuse angle, right? Because 90 degrees would be about here, and this is greater than that. So I'm going to call that an obtuse angle, and then if this touched, if I drew my drawing properly, then that would also be an obtuse angle. Okay, I'll see you next time.